Good afternoon, everybody, and welcome to this afternoon's or this morning's webinar on the LigoDLB series, specifically the LigoDLB 515 AC. We're going to be starting in just a moment. We're going to let a couple of stragglers time to be able to sit in and attend the webinar. My name is Jason Hintersteiner. I'm the Director of Business Development here at LigoWave. And for the next half hour, we're going to be talking about point-to-multipoint, specifically the LigoDLB series, and are focusing on our LigoDLB 515 AC. We have a special surprise in store for attendees. For those of you who stick it out to the end, and we're only going to go about half an hour, we're going to do a draw for a free pair of 515 ACs. So please stick around to the end for that. As always, if you have questions, please put them in the chat window, and I will address them at the end of the talk. Before we get started, I would appreciate it if somebody could just put something in the chat window to indicate that they can hear me, just to make sure that all systems are go and that we can begin. And also that you can see the presentation. Okay, I got confirmation that we can be heard, so we're going to go ahead and get started. So today we're going to talk about the LigoDLB series, which is our point-to-multipoint product for SMB and wireless surveillance applications. So the agenda for today, I'm going to talk a little bit about LigoWave. I'm going to talk about our value proposition on how we're distinguished in the marketplace. I'm going to talk about the LigoDLB point-to-multipoint platform. Then I'm going to dive into a greater detail into the product itself. Then we're going to do a Q&A. And as I mentioned at the end, one lucky attendee today will win a pair of LigoDLB 515 ACs for evaluation and use. So please put any questions that you have in the chat window or in the questions window, and I will answer them at the end of the webinar. So who is LigoWave? We're a global company. We're actually headquartered here in the United States in a suburb of Atlanta called Canton, Georgia. Our engineering and R&D takes place in Europe, and our factory is in Shenzhen, China. We've been in operation for over 10 years. We have over 15 branches located at various spots around the world, and we currently sell in over 100 countries worldwide. So why LigoWave? What makes us different than the competitors out there, and what's our value proposition? We do both in-house innovation and in-house production. So we do our own in-house development of hardware and software. We're not outsourcing hardware to reference designs. We're not, third-party applicationing stuff. We do some OEM work for customers, but our stuff is developed in-house. It's designed in-house. You'll also see as we get into the presentation that we have a proprietary protocol that we use for point-to-point and point-to-multipoint applications that gives us 30% faster throughput over our competitors. We also do in-house production. So we own and operate our own manufacturing facility. So that gives us higher quality control, and it also gives us faster response time and more flexibility in terms of responding to the needs of the market. So what's our value proposition to you? Our value proposition is support. We offer free pre- and post-sales technical support, and we have engineering support that's based on applications and solutions, not just products. We are an engineering-centric company. Profitability, we do very strict channel management and strict MAP MSRP enforcement. We have a partner program, which we will upload a handout of in a few minutes, for loyal customers in order to get discounts through distribution. And we also have higher distributor and reseller margins than most of our competitors. For our customers, we do a full inspection at our Canton, Georgia facility prior to US distribution. So in addition to items going through QA when they're in the factory in China, we also do a full inspection for more upgrades, custom configurations if needed, and so forth, at our facility here in the US before it gets sent out to distributors. And that gives us a substantially less than 1% defect rate. We have very few defects as a result. So let's talk about wireless backhaul and the LigoDLB applications and where these get used. And the answer is they get used pretty much everywhere. Our big focus with the LigoDLB is in wireless surveillance. That is by far our biggest application in all sorts of different verticals. It's also used for remote access control, interconnection of neighboring buildings. We use it to interconnect also to access points to provide outdoor Wi-Fi in areas where you can get power, but I can't get Ethernet or fiber. We use it in elevator shafts to provide connectivity inside the elevator cab. We'll also use it in mobile and temporary networks, such as man camps for oil fields, construction areas, first responders, operations, and so forth. So the kinds of verticals that we're in: parking lots, marinas, parks, campgrounds, RV parks, corporate and educational campuses, garden-style apartment complexes, construction, industrial, and emergency response. So pretty much anywhere where you need wireless backhaul, that's where we provide service, and you can do that very easily with our line of LigoDLB products. Our key features: this is a product that is purely designed for point to multi-point wireless backhaul. The LigoDLB is designed for short to mid-range applications. We do have long-range carrier-grade products in our rapid fire series and our Ligo PDMP series, which we'll have different webinars on. For the LigoDLB, this is our short to mid-range platform. All of the products have an either IP65 or IP66 ingress rating. They operate in a few different operational modes. The primary mode is our proprietary iPole 3. This is our proprietary TDMA-based protocol that allows 30% faster throughput, and we'll talk a little bit about that in a few minutes. We are also backward compatible with the standard wireless distribution system, WDS, and we have had customers who have integrated us with other vendors, which I normally do not recommend, but occasionally there's a need for that, and so we are backwards compatible so that if you need to install us in an environment where you have existing equipment and you're just swapping out individual units, we can run in a backwards compatible mode that will let us talk to other vendors' equipments using the WDS standard. There is special firmware that you could put on these if you wanted to run these as an access point, and you could also run these as a repeater. Within the software, we have diagnostic tools, including spectrum analysis, site surveying, ping and trace route, to allow for diagnosing the quality of links and what's going on, both Wi-Fi wise as well as in the spectrum itself from potential sources of non-Wi-Fi interference. In terms of models in the LigoDLB platform, we actually have quite a few. We have 2.4 gigahertz and 5 gigahertz models that are based on the 802.11n standard. These are older products. And with the iPole, those can get up to 170 megabits per second. Data throughput, compare that to a standard WDS link where that number would normally be maybe about 80 to 90 would be about the peak that you could get under ideal conditions for an 802.11n product. We also have 802.11ac products. Again, in WDS mode, the peak that you can usually get is around 300 to 350 megabits per second. We have measured throughputs of over 500 megabits per second across our links using the iPole 3. Naturally, we support WPA, WPA2. In terms of antenna options, you'll see in a minute, most of our products have an integrated antenna, but we do have products that will allow for an external antenna. So if you want to use an omni antenna or you want to use a custom antenna from a third party, we have a standard N-type connector on particular models as well. We have automatic channel and transmit power control, and there's a web interface and wizard for easily programming and setting up the link. I should mention that to set up an initial link literally takes about 5 minutes. If it takes you more than 10 minutes, well, you're doing something wrong, because it's really easy and it's really step-by-step. And we will have a detailed webinar coming up in a few weeks, I believe on June 12th, where we will actually be walking you through the step-by-step configuration of a point-to-point link in detail. So what is a wireless distribution system? A wireless distribution system basically connects two or more wired networks together wirelessly. And what happens is that it looks like a wireless wire. So traffic comes in from your switch or from your PC or whatever, and it's coming in on a standard Ethernet frame on a wired network. The wireless link will take that Ethernet frame, it'll encapsulate it into a wireless frame, transmit it across the link as necessary, and then when it hands it back to the other side of the network, it will strip off the wireless part and hand back the wired frame back to the other side of the network. So from both sides of the link, the devices that are on either side of the link, as far as they're concerned, there's a wire between them. It doesn't know anything about a wireless link between them. The nice thing about that is that you can transmit all of that layer 2 information, such as VLANs, such as individual MAC addresses on the other side of the link. All of that information gets preserved when you operate in this mode. And again, we have a proprietary version of WDS that does the same thing in terms of encapsulating layer 2 packets, but it takes certain optimizations in the protocol that allows us to get roughly 30% data throughput improvement. So in terms of models, the models we're going to focus on today are the 515AC. And what you're seeing here are basically 4 examples of our AC DLB product. The only difference really between these 4 different models is the antenna that's integrated. So the DLB 5AC has 2 external end connectors. So for hooking up either omnidirectional antennas or for a custom antenna. The 515AC, which we'll talk about, has an integrated panel antenna that's 15 dBi, and it's a 35-degree beam width horizontally and vertically. We have a higher gain version of this called the 520, which is a little bit bigger and is designed for a bit longer distances. That has a 20 dBi panel antenna in it and with a 16-degree field of view. And we're also going to be introducing at the beginning of June the LigoDLB 590 AC, which is a integrated has basically an integrated sector antenna. So it's got a 90-degree field of view, and that's for doing point to multi-point over a wider area. So that would be your point. And you'd have the 515's ACs as your multi-points. So our secret sauce, as I mentioned, is a proprietary TDMA-based communication protocol called IPOL. What this protocol does is that it basically optimizes the wireless protocol for point-to-point and point-to-multipoint, because Wi-Fi was never actually originally designed for doing point-to-point and point-to-multipoint. So the protocol has a lot of overhead in it that we strip out. That allows us to maximize bandwidth and minimize latency. Because it is a TDMA-based protocol, we eliminate contention between subscribers, so we do sequential polling. So everybody gets a turn for when they get basically a slot of when they're allowed to communicate. And when they're not allowed to communicate, they're not trying to talk. So, and as you add more subscribers to the system automatically adjusts and load balances based on how many clients are connected and how much traffic is trying to be driven by each client. There is integrated QoS mechanisms and advanced multicast handling. And as I mentioned, the algorithm is also self-optimizing, both in terms of balancing the number of remote clients, as well as being able to dynamically adjust channel and transmit power as needed. If you're interested in reading a little bit more detail about how IPOL works, I've included the link here. You could basically just go to our website and look for IPOL, and you can download the technical paper on it. So let's talk about the 515AC, which is the model that we are featuring today. This is our smallest access point model. It's about the size and weight of a large deck of cards, to give you some visualization of how big it is, because it's really, really tiny. It's very easy to mount. It's very easy to configure, and it is IP65 rated with a 30 dBm radio and a 15 dBi antenna built in. This is what the antenna pattern looks like. So you can see it's a roughly 35 by 35 degree patch antenna with a 15 dBi gain. Built-in tools into the software. So we have site surveys. So what that does is that basically puts the AP in sniffer mode. It's listening for beacon frames, and it's basically locating neighboring Wi-Fi networks, and it'll tell you, okay, here are the neighboring Wi-Fi networks I see, what channel they're on, how strong I see them. We have an antenna alignment tool, which will actually measure the alignment with the remote DLB series AP and give you metrics in terms of how to improve that alignment if you need to. We have a built-in link test, which will measure the data throughput and link quality. We have a spectrum analyzer also built in, which now is not just looking at what's going on in terms of Wi-Fi frames, but it's also looking at any source of RF energy in the spectrum that you're operating in to see if there's any non-Wi-Fi sources of interference, which may indicate that you might want to change channels. We also have ping and trace route, which are your standard network diagnostics for indicating that you have connectivity. So to show a couple of applications, this is an example of an RV park where we have 18 NFT2AC outdoor access points, which are dual band access points for providing Wi-Fi network access to clients. And those are the red dots that you see in this figure here. Those are connected by 24 LigoDLB 515 ACs in the point to multipoint groups that you can see in the colors here. And that's done for wireless bridging. So from the access points perspective, it thinks it has a wired connection. In reality, what's happening is that that is now going across a point to point or point to multipoint link to get back to the main distribution frame. Now, one of the challenges that we always have in doing wireless bridging applications is that you can't always get line of sight. And sometimes you don't know that until you actually show up on site. This is an example of a project where the customer told us, oh yeah, from the main building, which is kind of nicely centered on the property, we're going to be putting up these roughly 30 some odd cameras, and you got line of sight to everything. And so we provided a design showing, okay, point to multi-point, where everything's coming back to the MDF. And in reality, of course, that turned out not to be the case. And when we got on site, the installer got on site, they basically told us that the buildings were 2-story, not 1-story, and there were all sorts of trees. So basically, we had to figure out paths to avoid all of the trees and all of the buildings in the way. So we have a slightly more complicated point to multi-point design that has to go through a few different hops in order to reach every remote camera location. Again, though, we can accommodate the environment by carefully tracing out, the paths to make sure that we have clear line of sight to everywhere where we need to reach. And sometimes we'll use centralized buildings as relay points. As you can see, for example, camo 7A in the brown in the lower left corner, or where the green connects to the red at cam 19. So we can use those as intermediate relay points. And this is something that our engineers will work with you on. So if you have a specific project like this where I'm putting up a bunch of cameras around a property, this is a very typical application for us. And you have line of sight issues and you're not quite sure how you're going to be able to do the hops. This is something that you can definitely work with us on and work with our engineers on, and we'll give you advice based on how to actually see everything that you need to see. So with that, I'm going to end the formal part of the presentation. It looks like a couple of questions may have come in. So I'm going to see if there are any questions. So please enter your questions in either the question window or the chat window. Does your tight beam step on customers, and do we need to allow for it? Let me see if I can parse this question. Basically, interference happens at the receiver. So most Wi-Fi tends to be omnidirectional, whereas our stuff is obviously directionally based. And our equipment is usually pointed at each other, so the bulk of the signal will be going from one unit to the other unit. Now, obviously, if you're using, a 35-degree antenna, right, there's some bleed over. Typically, you more have to worry about the Wi-Fi interfering with our link than you have to worry about our link interfering with the Wi-Fi. But generally, that's one of the reasons that we include the spectrum analysis and the packet sniff, the beacon frame, so that you can actually see what else is on that channel that can be heard by both of the APs, so that you could pick a channel that is not currently in use. Hopefully that answers your question. If not, please feel free to follow it up. So demo units are available for customers to try. Absolutely, we do have a demo unit program where for the 515 AC, we can get you a pair at 40% off MSRP, and if you're interested, we can have a chat afterwards and get you the paperwork for that. It's basically a 30-day free trial. We take a credit card number to, so if you don't return the equipment, we charge you for it. If you return the equipment within 30 days, there's no charge. And I'll stick around for another few minutes for anybody else that has any questions. Again, though, thank you very much for your attention today, and look forward to seeing you guys on a future webinar.